The legs of the human body play a fundamental, multidimensional, and irreplaceable role in maintaining movement, balance, posture, circulation, neurological coordination, evolutionary adaptation, and overall physical and psychological well-being, and from a scientific and academic perspective, they represent one of the most complex and functionally integrated systems in human anatomy, consisting of bones, muscles, joints, ligaments, tendons, nerves, blood vessels, and connective tissues working in precise coordination to enable locomotion and stability. Anatomically, the legs are divided into three major regions: the thigh, the lower leg, and the foot, each contributing uniquely to weight bearing and motion, with the thigh containing the femur, the longest and strongest bone in the human body, which connects the pelvis to the knee joint and supports the majority of the body's weight during standing and movement, while the knee joint itself is a highly specialized hinge joint stabilized by ligaments such as the anterior cruciate ligament and supported by cartilage structures like the menisci that reduce friction and absorb shock. The lower leg consists of the tibia and fibula, where the tibia bears most of the body's weight and transfers mechanical force from the knee to the ankle, while the fibula provides lateral stability and muscle attachment, and the foot, composed of 26 bones, numerous joints, and arches, acts as a dynamic platform that adapts to uneven surfaces, maintains balance, and enables propulsion during walking and running. From a physiological standpoint, the muscles of the legs, including the quadriceps, hamstrings, gluteal muscles, and calf muscles, are among the strongest in the human body and function through cycles of contraction and relaxation controlled by motor neurons, allowing movements such as walking, running, jumping, squatting, and climbing, while these muscles also play a crucial role in maintaining posture and preventing falls by making continuous micro-adjustments in response to sensory input. Neurologically, the legs are deeply integrated into the central and peripheral nervous systems, with sensory receptors in the skin, muscles, and joints providing constant feedback to the brain regarding pressure, position, temperature, and movement, a process known as proprioception, which enables the brain to coordinate complex movements without conscious effort, while the cerebellum and vestibular system work together to regulate balance and spatial orientation. From a biomechanical perspective, the legs function as lever systems that optimize energy efficiency by converting muscular force into forward motion, following principles of physics such as torque, momentum, and ground reaction forces, and studies in biomechanics have demonstrated that human bipedal walking is one of the most energy-efficient forms of terrestrial locomotion, allowing humans to travel long distances with minimal energy expenditure. Evolutionarily, the development of bipedalism marked a critical turning point in human evolution, as walking upright on two legs freed the hands for tool use, object carrying, communication gestures, and complex manipulation of the environment, while also influencing changes in pelvic structure, spinal curvature, and muscle distribution, ultimately contributing to the expansion of brain size and the emergence of advanced cognitive abilities. From a circulatory perspective, the legs play an essential role in venous return, as the contraction of leg muscles during movement acts as a secondary pump that assists in pushing blood back toward the heart against gravity, a function known as the skeletal muscle pump, and when this mechanism is compromised due to prolonged immobility, it can lead to medical conditions such as edema, varicose veins, or deep vein thrombosis. Endocrinologically, physical activity involving the legs stimulates the release of hormones and biochemical signals that regulate metabolism, bone density, and muscle maintenance, demonstrating that leg movement has systemic effects far beyond locomotion alone. In medical science, the importance of the legs is evident across multiple disciplines including orthopedics, neurology, physiotherapy, and sports medicine, as injuries or disorders affecting the legs, such as fractures, arthritis, muscle atrophy, nerve damage, or joint degeneration, can significantly reduce mobility, independence, and quality of life, particularly in aging populations, where leg strength has been shown to be a strong predictor of longevity and overall health. Psychologically and socially, the ability to walk and move independently is closely linked to self-esteem, autonomy, and mental well-being, as limitations in leg function often lead to social isolation, anxiety, and depression, underscoring the deep connection between physical mobility and mental health. In the context of modern technology and rehabilitation, advancements such as prosthetic limbs, robotic exoskeletons, and neural-controlled artificial legs highlight the central role of legs in human life and the scientific effort invested in restoring their function when lost. While in sports and physical performance, leg power, endurance, and coordination are critical determinants of speed, agility, and strength. From a physics standpoint, laws such as Newton's third law explain how the legs generate forward motion by exerting force against the ground, which in turn produces an equal and opposite reaction that propels the body forward, illustrating the integration of biological structures with physical laws. Overall, the legs are not merely structural supports or tools for movement, but rather a sophisticated biological system that integrates mechanical efficiency, neural control, circulatory support, evolutionary adaptation, and psychological significance, making them indispensable to human survival, functionality, and progress. And scientific understanding of the legs continues to expand through research in anatomy, physiology, biomechanics, and medical sciences, reinforcing the idea that the legs are a cornerstone of human health, mobility, and evolutionary success.